Right, so let me share the slides. I hope you guys can see the slides. Today we are going to continue what we have learned in chapter 5, the last part in chapter 5, which is on cement, cement industries. But perhaps before that, probably we can recap a bit what we have learned yesterday. So yesterday we have learned about ceramics and also glass. Okay. Right. So we have learned about clay. What will be the composition of clay, and then the types of ceramics that we can found, the production of ceramics from traditional methods, and also the production of advanced ceramics. For the traditional ceramics, we have a different techniques. Okay, for example, the wheel throwing, slip casting, and also hand building. For the hand building, we have another subclusters. We have a pinch pot methods, a coil construction, and also a slab construction. The production of modern ceramics will be more detailed as compared to the traditional ceramics, where the material will be first pulverized, will be first crushed and ground, and later during the mixing, it will be inserted into the molding. Okay, and after that, the molded ceramics will undergo machine process. Actually depends on like turning, drilling, cutting, and after that the curing using sintering process. This is where the ceramics been put in the furnace or in the oven, and finally a finishing process where grinding, polishing, glazing, and others will be taken into account. Right. So we have also looked at different types of modern ceramics production, different types of molding. We have injection molding, we have isostatic pressing, and yesterday we have also looked at glass. And so what does it mean by glass? A glass is basically amorphous ceramics, which is made mainly from silica. And we have three types of glass: soda lime glass, lead glass, and also borosilicate glass. Each and every glass have its own different properties. Of course, the uses of glass could be various. And for the process of producing glass, it can be like press glass processing, blow molding, plate glass drawing, and today we are going to continue with cement. Right. So for cement, you can see it widely being used in construction, building, and maintenance. Cement is a crystalline compound of calcium silicate and other calcium compounds having hydraulic properties. The main ingredient to produce cement is basically calcium silicates. I mean the silicates SiO4 and calcium silicate CaSiO4. This is actually the main ingredient, okay, for the cement because it's quite durable, okay, it's quite hard in properties, okay, and most of the cement actually can be or should have a hydraulic property. So what does it mean by hydraulic properties? Hydraulic properties, it means that the material itself have fluidic properties. It can actually move like a fluid. Okay? But when it hardens, it becomes a very rigid, very hard materials, which at the same time having or need a very high pressure or tensile to break it. So you might heard about Portland cement. So if you go to any hardware shops or if you see any cement pack, the sack of cement, it's written Portland cement. So what does it mean by Portland cement? So Portland cement is basically a hydraulic cement produced by pulverizing clinkers, consisting essentially of hydraulic calcium silicates, usually containing one or more forms of calcium sulfates as the interground addition. So in this case, you are not going to have only calcium silicates, but also the addition of clinkers. So we will learn about clinkers after this, but clinkers is basically a materials that is added to make the cement properties become more durable. So for example, gypsum or calcium sulfate. So this could be one of the useful clinkers that normally added into the cement. The uses of cement, of course, it is mainly used in the fabrication of concrete and also mortars. So you have a different types of cement that perhaps you might not know, but probably I can share. So for cement, we have a so-called cement and also cement grout. Okay. So what does it mean by cement mortar and also cement grout? So cement mortar means that you have cement plus with sand plus with aggregates. So aggregates um, that normally used is like rocks, pebbles, or other types of material. Meanwhile, for cement grout, it's just solely on cement. Okay, so what's the difference between cement mortar and cement grout? Cement mortar, it means that it is a reinforced, okay, reinforced cement. You add a binder, you add the aggregates to make the materials become hardened. So you will see a lot cement mortar being used in the production of concrete. Okay. Meanwhile, for cement grout, okay, this actually being used for finishing process. Probably you've ever seen people when they do floor cement, masa dia buat lantai cement tu, okay, they will only, I mean, put cement and then with water, okay. The objective is basically to produce a smooth uh, cement, surface. Then they only use cement as the finishing materials, not using sand or aggregates, because this one it would be slightly rough. The surface is slightly rough and not really, I think, being used. Okay, so even you can see over here a mortar holding weathered bricks. This is actually bricks, and this is actually cement mortar. Okay, because when you see cement mortar is functioned as a glue, and it needs a reinforcing material to make the materials become hard. If you use only cement, then it will be slightly less durable, then it can easily break. The modern uses of cement, of course, in building for the production of cements, floors, beams, column, roof, piles, bricks, mortar, panels, and plaster. It is also being used in transport. So you might see some concrete highway, concrete highways or concrete road. Okay. Probably you will notice this if you go to any highway or any roads, normally highways. Approaching to the exit or approaching to the exit, Plaza Toll, you will see that the road is actually made from concrete. So it is not really like bitumen or pavement road. So this is actually to ensure a more rigid structure without sinking, without having instability in terms of moving. So that is why you see a lot of concrete roads in the highway. Other than that, concrete is also used for pipes, drainage, canals, dams, tanks, pool, and etc. For civil users, it is used to build piers, okay, docks, retaining walls, silo, warehouse, and others. And also in agriculture, where it is also used for building, processing, housing, and also irrigation and saliran. Irrigation, it means saliran. Okay, so the cement source and raw materials. This is actually the main ingredient that you will see a lot in cement. So what you should have in cement, of course, you should have lime, okay, calcium oxide or shell limestone. These are a few examples of lime material. Silica is also needed, okay. You can have actually silica from clay, sand, and also shell, okay. And other than that, there's a binding materials, okay, which in this case using aluminum oxide, okay, that you can get it from clay and fly ash. And finally, you can also add iron ore, iron oxide into the cement. So there will be a specific composition of this material um, to produce a cement. So if you want to consider later on to produce any cement factories, these are the few active ingredient that is needed to produce cement. So normally this will be the ratio to produce Portland cement. Okay. You have like around 5/8 of calcium oxide, 1/5 silica, okay, or aggregates salts or rocks, 1/10 of alumina, 1/20 of iron ore, and also 1/20 of calcium sulfate or gypsum. Okay, so this actually a standard uh, formula or a standard ratio to produce Portland cement. You can find it in different percentage depending on the application of cement, but this is actually the most commonly used percentage of materials. And in cement industry, there will be some shorthand chemistry just to simplify the materials. Okay, we always noted C as the lime, or also known for calcium oxide. So S is actually for silica, A is actually for alumina, H is actually for water or hydrated, S bar is actually for sulfate, and F is actually for iron ores. So that is why, I mean, some people, they just write a shorthand chemistry for cement or their products. They just write like C3S, C3A, C3AF. What does it mean? So this actually the formula of cement that they produce is just a shorthand. Right. Clinkers is actually artificial minerals that contains all these materials. So the composition or the mixture of all these materials will actually produce a so-called clinker. So these clinkers will be a hardener that normally added into the cement. How we can produce cement? So cement can be produced, of course. The first one is you need to mine limestone, because the limestone or lime is basically the main active ingredient in making cement. So that is why you will see a lot, in fact, in Jelapang, we have like the biggest, one of the biggest cement factory, YTL Cement. You can see, I mean, if you travel back to hometown or what, this industry is actually located near to the limestone source. So it can be mined, it can be extracted. So what happened after that? This excavator will dump the limestone and it will goes into the crusher. So the limestone will be first crushed and then it will be forming a rough ground limestone, and it will be crushed again, it will grind again to form a fine ground limestone. And after that, clay will be added, okay, into the mixture. So what happens is that it goes into the proportioning equipments. Okay, it will actually introduce a specific amount of clay, a specific amount of sand, and after that it goes to the grinding mill. Okay, so the grinding mill, okay, will grind again the mixtures or the aggregates before it will be activated. So it goes to this preheat tower. So this preheat tower is just to activate the material. It's just being heated slightly before it goes into the rotating kiln. So rotating kiln is actually function as a rotating furnace. Okay, this is actually where the process will happen, where most of the mixture will be turned into clinkers. Okay, so next the clinkers will goes into the cooler. Gypsum will be added after that, okay, as a binder to make the material become hardened, and finally it will be distribute, or it will be proportion to the grinding mill. So after that, it will be stored and also it will be shipped. So this is actually the overall process of making cement. Well, in fact, the detailed explanation of Portland cement manufacturing, first, limestone is first reduced to the size around 125 millimeters, and then reduced again to 20 millimeters, and after that it will be stored. The raw material will be ground to powder and also will be blend. So that is why you will see over here, okay, some specific amount of sand, clay, and iron ore will be introduced. It will be later on grind, and then after that it will be blow, okay, to remove dust and others. Or the raw materials will be ground and mixed with water to form slurry and blended. So in this case, you have like two types. You have a dry process and also you have a wet process. So wet process actually mix the all ingredients, okay, making it become wet. And after that, what happened is that this mixture will be like crushed. It will like harden. It will be crushed. Okay, and this, but first the slurry mixture will be mixed and also will be blended. Later after that, the mixture will goes into the kiln for activation. Most of the minerals will be converted into oxides. Okay, so you have a rotating kiln. So the rotating kiln actually have a different temperature range at one end to another end. Okay, so the function is basically to purify the materials, um, as well as to activate the cement materials. Okay. Right. So after that, it will be forming a clinker. So the mixture will later on forms like a bigger particles. It's like a marble size that we call it as clinkers. So these clinkers will be goes into a mixing container where gypsum will be added later on. So this is where the rotating kiln play the role. You will see that the rotating kiln have a different distance, okay, from one end to another end. So the temperature is basically different. So the one that is near to the exhaust gas is less in temperature. The one that is near to the output, okay, it will be slightly hot. So you will see that where the raw material will be fit in. So at this temperature, this is where the dehydration process starts to form. Most of the water will be hydrated. Okay, and then here most of the clay will be decomposed. Okay, lime will be decomposed. The formation of initial compound. Okay, the formation of the first clinkers, which is C2S, and then after that, the first formation will be melt, and it will form later on C3S. Okay. So after the clinkers have been formed, okay, burning charge raw mix chemically into clinkers, not for stage of preheat, okay, and a flash furnace and shorter clean. Okay, so the four process actually depends on this one. You have like dehydration zone, calcination zone, clinker zone, and also cooling zone. This is actually the four process that happens in clinkers. Right. In the rotating clean, okay, the process is mainly a pyro process because it involves heating. So of course, the temperature that is used during this process is very high, around 1000 over. Okay, and you will see that this is actually part of the rotating clean. Okay, if you go to any cement industry, unfortunately this year we cannot go anywhere. So you will notice that there is long rotating pipes. So this is actually the rotating clean. Right. And finally, after the clinkers is mixed with gypsum, it will form a so-called Portland cement. Okay, and after you have mixed it with gypsum, it will be ground again. Okay, it will be ground. That's why you see there's a grinding mill. It will be blown. Okay, so when it blown, so most of the dust will be like moved out. Then the cement will be stored, and after that, it will be stored in the tanker. All right. So more details on the cement production you can watch from this video. Okay. So any questions so far for cement industry? Any question? Yes, no? Right. We'll move on to a new chapter. I have actually uploaded your chapter 6 in your e-learning. Chapter 6 is basically on nitrogen-based industry. Probably today we just go slightly a bit on the introduction. Let me share the slides with you guys. Okay, so nitrogen-based industry, this is actually completely different from the other 5 chapters that we have learned. So for the first chapter is more on like inorganic materials or what. Nitrogen is still considered as inorganic, but I think this chapter you will have a slight organic I think materials that you will learn. Okay, so when we talk about nitrogen-based industries, anyone have some idea what would be the types of product that normally will be concentrates on nitrogen-containing chemicals? Anyone have an idea? Can someone give an example? Kau yang shirt, kau yang seat, sorry. Kau yang shirt, are you around? Yeah. Oh, you sound a bit tired.
No.
Okay. So, can you give me some examples of nitrogen-based or nitrogen-containing chemicals that you know?
Fertilizer.
Okay, fertilizer. Why fertilizer? Why do you think it is fertilizer? Any idea?
No.
Okay, you didn't do any gardening at home, eh? Okay,
No.
all right. Um, Nabila Huda, Nabila Huda ada ke? Nabila Huda tak ada. Nur Syakira, Nur Syakira ada tak ada? Pun tak ada. Okay, right. Basically, when you consider about fertilizer, when we talk about fertilizer just now, Yorkshire give examples of fertilizer. You have to understand that in fertilizer, the most important element that you need to consider or need to stress more is NPK, nitrogen, phosphorus, and also potassium. Okay, so why this element is considered important? Because the plant, okay, need all this material, okay, to ensure its growth lah. Okay, so it needs nitrogen, it needs phosphorus, and it also needs potassium. So without this element in your fertilizer, then the fertilizer will not going to be a good fertilizer. Okay, so that is why some examples of fertilizer like you have urea, okay, you have a phosphate fertilizer. All these are actually a useful type of fertilizer. So in this chapter, basically, you're going to learn about nitrogen, okay, and then nitrogen cycle. I believe this one also you have learned it during your high school. Nitrogen cycle, the production of ammonia, urea, and also nitric acid. So this will be the products of nitrogen-based industry, the part of it, right? Ammonia, urea, and also nitric acid. So you have to remember all this process, and also the application of nitrogen-based products. All right. So for nitrogen, you know that in chapter 2, how you can produce nitrogen gas, and the most abundant amount of gas that you can see in the atmospheric gas is actually nitrogen gas. So nitrogen was first discovered and isolated by Scottish physician, okay, then Rutherford in 1772. Okay. It forms about 78% of Earth's atmosphere. It occurs in all organisms, primarily in amino acids, normally in proteins, in nucleic acids, DNA and RNA. You have all nitrogen-containing amino acids, and in the energy transfer molecules of ATP, adenosine triphosphate, ATP. So many industrial important compounds such as ammonia, nitric acid, organic nitrates that is used for propellants and also explosive, and cyanides contains nitrogen. Synthetically, it produces ammonia and nitrates, and these are the key industrial fertilizer and fertilizers nitrate, where it is also the key pollutants in the eutrophication of water system. So of course, when you produce like nitrates fertilizer, this can also harm the environment because of the nitrates can be easily leached into the water. Okay. So of course, nitrates is useful for the soil and also for the plant, but if it is leached and goes into the stream, it goes to the river, then you know that your water supply will be contaminated with, and higher concentration of nitrate is not good for living organisms. Okay. All right. So nitrogen cycle. So what does it mean by nitrogen cycle? Okay. So God have created, I think, this nature having a very special features where it can actually generate different types of nitrogen containing compounds, and this nitrogen containing compound can be useful for plant growth, animals, bacteria, and whatsoever. Okay, so the production of different types of nitrogen uh, compounds is known as nitrogen cycle. The nitrogen cycle is the process by which nitrogen is converted between its various chemical forms. This transformation can be carried out through both biological and also physical process. Right. So the forms of nitrogen compounds that you can see from the nitrogen cycle formation, it can be the formation of ammonium, nitrate, nitrate, nitrous oxide, and also nitric oxide. So other than that, a nitrogen gas can also be formed. So that is why in nitrogen cycle, you have 6 different steps. You have the first one known as nitrogen fixation, second one, nitrogen assimilation, third one, ammonification, fourth, nitrification, fifth, denitrification, and finally, sedimentation. Okay, so we are going to look at this one by one. Right, so the first one, nitrogen fixation. What does it mean by nitrogen fixation? It means that the conversion of free nitrogen of atmosphere into biologically acceptable forms of nitrogenous compound. Okay? So there are several ways to convert nitrogen gas into more chemically reactive form. The first one is known as biological nitrogen fixation. Second, physicochemical nitrogen fixation, and lastly, industrial nitrogen fixation. All right. So basically, when you have nitrogen gas in atmosphere, so what happens is the bacteria in soil and also in roots will convert or will actually digest this to form ammonium. So this process is actually known as biological nitrogen fixation. Some symbiotic bacteria, blue-green algae, and some free-living bacteria are able to fix nitrogen as organic nitrogen. Okay, the types of symbiotic bacteria will be like rhizobium. Okay, the symbiotic blue-green algae, you can have like nostoc, anabina, and then the free-living bacteria, azotobacter, Clostridium, okay, Derzia, Rhodospirillum, and others. So all these are actually the examples of bacteria that can actually convert nitrogen gas into organic nitrogens. The second process is known as physicochemical or non-biological methods. In this process, atmospheric nitrogen combines with oxygen, as in ozone, during the lightning or electrical discharge in the clouds and produce different nitrogen oxide. So in this case, you have like nitrogen gas reacted with oxygen, okay, to form nitrogen oxide, and then from this, the nitrogen oxide will be converted into nitrous oxide. Okay, the nitrogen oxide get dissolved in rain and reach Earth's surface that they can react with mineral compound to form nitrates and other nitrogenous compounds. So the nitrous oxide will be later on react with water. This is actually because of in your clouds, you have lots of water molecules. Then it will form nitric acid. Okay, so this nitric acid is basically when it rains, we call it as acid rain. So if you have like nitrous oxide or sulfur dioxide gas, okay, when it reacts or when it combines with water molecules, it will form nitric acid or sulfuric acid. So that is why, I mean, during rain, if you have a high concentrations of nitrous oxide or probably sulfur dioxide, then this can be categorized as acid rain. So what happens is that the acid rain will react with calcite or calcium carbonate to form different types of um, nitrates or nitrogenous compound. Like in this case, calcium nitrate. Okay, so the last methods for nitrogen fixation is known as industrial nitrogen fixation. Okay, in industrial nitrogen fixation, the process is occurring at industrial scale. Under the great pressure, a temperature of 600 degrees Celsius, and with the use of iron as a catalyst, hydrogen and atmospheric nitrogen can combine to form ammonia. This is known as Haber-Bosch process. So in this case, you convert nitrogen into ammonia, okay, by reacting it with different types of gas. Like for example, in this case, hydrogen gas with the presence of iron catalyst and at high pressure and high temperature. It will form ammonia, and this process is well known. It's known as Haber process or Haber-Bosch process. Right. So that is actually a few methods in nitrogen fixation. I believe for the other parts of nitrogen cycle, assimilation and others, we can actually continue it tomorrow. So far, is there any question that you would like to ask? And tomorrow we don't have any lecture. I'm sorry. Next week. Any questions so far? Okay, so once again, please refer to your chat box. I have actually shared the link for Group 1 until Group 5 Group 1 until Group 5 videos. The videos that you guys should watch, okay? Basically on the production of bricks, production of biofertilizer, okay, production of cement, extraction of gold, and also the production of technical glass. So later after this, I will share, I mean, in the WhatsApp group, the complete videos, including for Group 6 and also Group 8. Okay, so any questions so far? Ada soalan? Ada apa-apa nak tanya? Itu yang fasting month, morning very slow response from you guys. Okay, well, if there's no other question, then I will adjourn the class. Thank you very much. I hope to see you next week on Tuesday, and stay safe and enjoy your weekend. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Thank you, Doctor. Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Welcome.